Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to implement a stack in Java. So friends, in my previous tutorial I discussed how to represent a stack. We saw that it is a LIFO data structure, which means that element which got inserted last would be the first one to be removed. And we also discussed that the elements are inserted and removed at the one end, which is represented by top. So friends, in this tutorial we will discuss how to implement a stack in Java. We will discuss few of the methods which it implements, such as push, which actually inserts an element into the stack, and we will also discuss pop method, which removes the last node inserted from the stack. So friends, in this tutorial we will implement a stack using a linked list. So friends, as you know that linked list is represented by a list node where it contains two things. One is the data and other is the pointer to the next list node. So when we implement a stack class, we usually keep two instance variables. One is top and another one is length. So in our previous tutorial we discussed that this top node is used to insert and remove the elements from the stack, and here the instance variable length, which represents the size of the stack. So friends, let's see the demonstration of this algorithm. So friends, when we initialize a stack, first top points to null and the length is 0. So here you can see top is pointing to null, and as the stack is empty, the length is 0. Now suppose we want to add an element having data as 10. So we'll call this push method and pass the data into it. So when we call push and pass data as 10, we know that data is 10. So let's see the execution of this method step by step. So in order to push an element into a stack, we first create a temporary list node having a data which we have passed as an argument. So it would look something like this, that we have created a list node having data as 10 and its next pointing to null, and you see the name of the list node is temp and it's pointing to that particular node. Moving ahead, now in order to insert this node into the stack, the first step we do is we assign the value of top to temp.next. So friends, here you see temp points to this node and its next points to null, and when the stack is empty, we know that top is also pointing to null. So in the first step we are simply assigning a null value to temp next. So it would look something like this. So after this step, temp next is pointing to null and top is also pointing to null. Moving ahead, and then we'll assign the value of temp to top. So here you see top points to null, and when we'll assign the value of temp, so temp is pointing to this node. So after this step, top will point to the temporary node. So it would look something like this. And in the final step, as we know that we have inserted this temporary node, we'll increment the length of the stack by 1. So here you see when this method gets executed, the stack looks something like this. The top is pointing to a node having the data which we passed into the push method, and its next is pointing to null. And therefore the stack has one element, therefore the length is 1. Now suppose we again call push method and pass data as 15. So let's see execution of this method step by step when length is 1 and top is already pointing to a node. So here when we have called push 15, so the data is 15. So here we'll create a temporary node, and this temporary node will hold the data which we pass into this push method. So here you see we have created this temporary node having data is 15 and its next pointing to null. Moving ahead. So friends, the next step is we'll assign the value of top to temp.next. So currently temp.next is pointing to null. So in order to insert this node into the stack, we are assigning the value of top to temp.next. So we are doing something like this. We are removing this link and we are pointing it to top. So in this step we are assigning the value of top to temp.next. So now temp.next is pointing to top. Moving ahead. So as this node is now inserted, now top should point to this node. So therefore we are assigning the value of temp to top. So it would look something like this. So now top is pointing to the temporary node. Moving ahead. And we'll simply increment the length by 1 because now the stack has 2 elements. So friends, after this method gets executed, the stack looks something like this. So here you see the top is pointing to the node which we inserted last. So friends, this is how we insert an element into the stack. Now let's see the pop operation in which we remove the last inserted element. So we'll take the previous example. We know that first we inserted 10 and then we inserted 15. So in the pop, the last element inserted will be the first one to be removed. So let's see how this pop method works. So in order to remove the last inserted node, so what we'll do, we'll simply capture top.data into integer variable by name result. So we are storing the data inside this node into the integer variable result. Moving ahead. Now as we want to remove this last inserted node, we need to break this link. So once this node is removed, top should point to its next element. So for that we'll simply assign top.next value to top. So it would look something like this. And as this node is not referred by top, it would be garbage collected. Moving ahead. Now we have removed the node from the stack. So we need to decrement the length by 1. So now length becomes 1. So we'll simply return the value 15 from this method. Now you see the stack contains only one element and the length is 1. Now if we again call the pop method, so first we'll store the data inside this list node which is being pointed by the top. So we are simply assigning top.data into an integer variable result. And as we need to remove this node, we'll simply break this link and assign top to its next. So we are simply assigning top.next value to top. So top.next is pointing to null. So we are simply assigning a null value to top. So it would look something like this. And as this list node is not referred by top, so it would be removed. We'll decrement the length by 1 because the node is now removed from the stack. And finally we'll return the result. So friends, here you can see when the stack is empty, the length is 0 and top points to null. So friends, here we saw the demonstration of how to implement a stack in Java. So let's go to Eclipse and see the working code. So friends, in order to implement a stack in Java, I have just created one class by name stack. So in this class we will implement the stack functionality. So as we saw in the slide that stack contains few instance variables. So we'll create one instance variable of type list node by name top. So private list node top. And we'll also create an integer variable by name length, which will store the size of the stack. So private int length. So friends, as you can see, we are implementing a stack using a linked list, which is represented by list node. So we'll create a inner class of type list node. So friends, in our previous tutorial, we discussed how we can represent a list node in Java. So a list node contains two things. One is the data, so private int data. Another is pointer to next list node, so private list node next. We'll also create one constructor. So this constructor takes the data part. So friends, here we are implementing the stack using a linked list. So we have created this list node. Now once we initialize the stack, we know that top points to null and length is 0. So we'll create one constructor for this stack class, public stack, and here we'll assign a null value to top and length as 0. Friends, we will also create one method by name length, which will return us back the length of the stack. So public int length return length. We'll create one boolean method by name is empty, which will return us a boolean value whether the stack is empty or not. So public boolean is empty. So here we'll simply return a boolean value which will represent whether the stack is empty or not. So in order to know that the stack is empty, we'll simply check whether length is 0 or not. So if the length is 0, we'll simply return true, that stack is empty. And if the length is not 0, then we'll simply return a value of false, that stack is not empty. So we'll simply return length equals 0. Moving ahead. So friends, first we'll code the push method. So public void push, and in this push method we'll pass the data. So this data will be inserted into the stack. So in order to insert this data into the stack, we'll first create a list node and we'll give name as temp, and we'll create this list node, and inside the constructor we'll pass the data. Moving ahead, now the next step we'll simply assign value of top to temp.next, and then we'll simply assign the value of temp to top. So top equal temp, and finally as the data is inserted, we'll increment the length by 1. So friend, this is the push method. Now we'll implement the pop method. So public int pop. So friend, this method will return us back the value of last inserted node into the stack. So here first we'll put an if check, and the check would be is empty. So friends, if suppose the stack is empty, then we can't pop an element from the stack. So if the stack is empty, we'll throw an exception. We'll throw empty stack exception because we know that stack is empty and we cannot pop an element from an empty stack. So friends, if the stack is not empty, then the first step we'll create an integer variable by name result, and we'll assign the value of data stored in the top list node. So we'll do top dot data, and as we have stored the data inside the top, we can simply traverse to next node by assigning top dot next value to top. And finally the top has moved to its next node, so that node will be garbage collected, and we can simply reduce the length of the stack by 1, and finally we'll return result. So friend, this is how we pop an element from a stack. The stack also contains one more method by name peek. So what this peek method does is it simply returns us back the value which top holds. So it is nothing but returning a value of a last inserted node into the stack. So we'll create a method by name peek. So public int peek. So we'll also provide a if check here, that if the stack is empty, we will throw empty stack exception, and if the stack is not empty, then we can return top.data, because we know that top points to the last inserted node into the stack, and if we do top.data, we'll get the value stored in that particular list node. So friends, this is how we implement a stack in Java. Now let's see the demonstration of these methods. So in the main method, first we'll create a stack. So when we do new stack, we know that top is pointing to null and length is 0. So let's say we push few elements into the stack. So stack dot push, and let's say we give data as 10, (15) and 20. So friends, here in stack we have pushed 10, 15 and 20, and we know that initially top pointed to null, and as we inserted the data 10, it pointed to 10. Then as we pushed few nodes at 10, 15 and 20, so we know that top points to last inserted node. So if we print stack.peek, so if we are printing the peek value of the stack, we know that it prints the value of last inserted node. So if I run the program, you see it prints 20, because 20 is the element which we last inserted. And suppose I want to pop an element, so I will do stack.pop. So we know the top points to the last inserted node. So when we do a pop, 20 will be removed. And if I print stack.peek and run the code, so you can see it prints 15 the next time. When we do stack.pop, the last inserted element is the first element to be removed. So the 20 is removed, and stack contains 10 and 15. And 15 is at the peak position, so it printed 15. And if I simply copy paste this and run the code, so you can see the third time it printed 10 because we removed 15 as well. So here if you see, we have implemented push and pop in such a way that it is resembling a LIFO data structure, which is the element inserted last is the first to be removed. So friends, in this tutorial we saw how we can implement a stack in Java. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.